Okay guys, welcome back to part 2 of reactions in food lipids. I have selected several, not all. Number 1 is called hydrogenation, or more accurately partial hydrogenation. This is basically forced addition of hydrogen, see there, to the unsaturated bonds. 1, 2, 3, you can see the C's there, in unsaturated fat. So it is all about unsaturated fat. So because of that addition, with the helps of catalysts and pressure, we produce solid trans fat over here. See, trans. The process raises the fat melting point, so you harden the liquid oil into semi-solid fats. It's about hardening of oil. And according to our knowledge so far, fatty acid with most double bonds hydrogenate more quickly than less saturated ones. Okay, process can be controlled, like vegetable oil into butter. Yes, it is possible, while retaining high linoleic and oleic acids. The side effect of hydrogenation, number 1, the percentage of cis is changed to trans unsaturated fatty acid, and we have discussed before that cis is always better for human health compared to trans. And in trans form, linoleic acid, which is dietary essential, becomes biologically inactive. So we will discuss in class why is that so, and so what. And since unsaturation is reduced, the tendency of fat to oxidize is also reduced, and making the hydrogenated frying oil more stable. This is what the industry wants. You get longer frying time and higher smoke points. The oil becomes more stable. The industry loves this. Anyway, if you buy say peanut butter or any other solid fat like margarine, have a look whether they have trans fat listed in the label. You know, like this one have like 3 grams per serving. So get to know your products. Number 2 is called fractionation. Also, this is a separation process, very important in palm oil industry. Well, in a nutshell, it is an oil is separated into fractions with each specific properties. And typically, when we talk about oil, it's all about degree of saturation, melting point. The more saturated, the higher the melting point. Via fractionation, it is possible to split. Yeah, so you want to split the oil into higher melting point components and lower melting point components. You allow crystal portion to be separated from liquid portion, and whatever portion you have, you can further fractionate it. Yeah, so we use example of palm oil, melting point of around 38 degrees C. You can fractionate palm oil to produce variety of fraction that can be applied in a variety of products. Yeah, you start from palm oil, melting point 38 degrees C, saturated fatty acid 51, monounsaturated fatty acids 38, and PUFA 10. Yeah, so after fractionation, you produce olein, and then you produce stearine, and further fractionation, you produce superolein, mid fraction, soft stearine, and super stearine. So from here you see the melting point of superolein is 5 degrees C. Whoa, very low. And please note the SAFA, MUFA, and PUFA content as we go along. Mid fraction has 28 degrees C melting point, and soft stearine 48. Super stearine, which is the most saturated, melting point is 60 degrees C, the highest melting point. So now you have 4 different fractions. Superolein being the least saturated, and you have the super stearine here, the most saturated. So you have many options now to play with. You can mix them in order to produce strategic products. Example application with super or lean, you can use it as alternative for liquid oil because you know to make chocolate spread you need something with a lower melting point. And then you have mixed fraction is slightly higher melting point, filling fats and cream fats. You can combine stearine with super stearine to produce substitute hydrogenated vegetable oils and fats in margarine. Therefore you can reduce trans fat here. Yeah, soft stearine can be used for bakery softening. So by having fractionation, we produce several fractions with different melting points, and by mixing of different fraction or with other oils, you can produce product with specific melting point which is necessary for certain applications. Okay, then we have interesterifications. This is removals of fatty acids. This is, remember, glycerol, the blue line, and then we have free fatty acid 1, fatty acid 2, fatty acid 3. So if you want to remove this, you break it down. Normally they use some metal salts and or lipase, and there are subsequent rearrangement or recombination. So you reform or you recombine into numerous configuration. So the green fatty acid here go up, and then this brownish fatty acid come down here. So you have a new configurations. So because of that, you have a new properties. Yeah. So it is possible to modify the distribution of fatty acids within a triglyceride that yield triglyceride with desired properties. So industrially, hard fat is interesterified to produce mixed glyceride that offer improved creaming. So you can recall the ester bond that attach Fa to glycerol, this particular ester bonds. This is because of this bond ester, we call it interesterification. Okay, we call that. Okay, the coarse crystal grainy textured fat like lard can be chained into lower melting point. Therefore you have finer crystal size, you have a product more plastic and smoother texture and mouthfeel. Okay, the concept is similar. It is even possible to produce lower calories of TG if you have a shorter chain of fatty acids being new reformed there in this particular chain. Okay, number 4 is hydrolysis. To separate fatty acid from glycerol portions of a TG require heat and water molecule. So you have TG there, 3 molecules of water and heat. You can yield 3 fatty acids and glycerol. If you keep on heating and heating, you will yield acrolein, which is bad, and that is due to glycerol breakdown. Acrolein is odorous and irritating fumes in the smoke of overheated TG. Yeah. Okay, another term is called hydrolytic rancidity. This is when the stored fat becomes rancid by the hydrolysis reaction with water. So this is different from by applying of heat into the system. This is by storage. So the free fatty acids is produced through hydrolysis. For every molecules of water that combines with TG, 1 fatty acid is liberated. Yeah, if you have a short chain fatty acid, the flavors and odors are objectionable. You should be familiar. You leave butter at room temperature for too long, you can expect hydrolytic and rancidity. This is it will cause butter to smell bad and taste bad because butter TG has high content of C4 butyrics and C6 caproic acids. Okay, but if it is long chain fatty acid, no issue with odors and flavors. Okay, finally we come to oxidation. This is when oxygen reacts with double bonds of unsaturated fatty acids, yielding small organic compounds, which in turn generates undesirable rancid odors in food that contains oxidized fats or oils. And rancid foods are not edible, the original fatty acids along with their nutritional values are lost. So we'll discuss why it is undesirable, these free radicals, and how to stop in the reaction from going on. I don't have voice, so I'm going to invite my friend Andrew to explain to you about fat oxidation.
Thank you, Professor Azar. Now let me help explain fat oxidation. During the first step called initiation, free radicals are formed as loosely bound hydrogen atoms near the carbon double bonds of a fatty acid RH are lost. The resulting fatty acid free radical reacts with oxygen to produce an activated peroxide, or peroxyl free radical. This radical reacts with a nearby unsaturated fatty acid RH to remove its hydrogen atom, which generates hydroperoxide, ROH, from the peroxyl free radical and a new fatty acid free radical R. from the fatty acid. The newly formed fatty acid free radical reacts with oxygen, and the cycle is repeated, which is termed propagation. At some point the hydroperoxide, ROH, splits away through chemical decomposition into smaller short-chain organic molecules, including aldehydes and ketones. These contribute oxidized and rancid odors and flavors to the fat. Lipoxidation ends when all of the molecules have reacted, or when two unstable radical species react with each other, or when an antioxidant reacts with a radical, which stops the chain reaction. This is called termination of lipoxidation. Back to you, Professor Azar.
Thank you, Andrew. So that's all for fat reaction that I've selected. We're going to meet again some other for discussion in the class. Okay, guys. Thank you and happy learning.